Good morning, children. How are you all? Okay. So in the last class we have studied about the mixtures. Okay. The chapter is matter around us below. In that we studied about the what is a mixture and what are the different types of mixtures. Okay. So that is a two or more substances combined physically is called as a mixture, and there are two types of mixtures: heterogeneous mixture and homogeneous mixture. Okay. After that, we have to study about the solution. So, what do you mean by a solution? Okay. So, see here, solution is also the mixture. Solution is also a mixture. Usually, in the solution means take the example for sugar solution. In the sugar solution, solution is nothing but the homogeneous mixture. And here in the solution there are three terms: solution, solvent and solute. Okay, so what do you mean by solution? Solution is nothing but it is a homogeneous mixture, and completely dissolved. The particles or the substance which dissolves completely, and here the solution, for example, water and sugar solution, salt and sugar solution. Okay, so in the solution it is a homogeneous mixture, and here there are terms related to the solution, that is a solute and solvent. Solvent means water. Solvent is nothing but it is the component in which it dissolves the solute, which dissolves. That is, for example, water. In the sugar solution, water is the solvent. What is a solvent? And which will dissolve in solvent, that is called as a solute. Just here, solvent means water, solvent, solution and solute. Okay, solution is nothing but it is a homogeneous mixture of a solute and solvent. Okay, solvent is nothing but which dissolves, means which dissolves the solute, and solute is nothing but it will get dissolved in the solvent. Okay, so here the solution is nothing but there are different types of solutions. That is here it is a homogeneous mixture. Especially solution is nothing but it is a homogeneous mixture. Example, here sugar and water. Here sugar and water, and the properties of solution carries 3 marks. What is the solution, and write the properties of the solutions. First you should write the what is solution. Solution is nothing but it is a homogeneous mixture. Example is nothing but sugar in water, or sugar, it is called sugar solution, or salt water, that is a salt solution. And properties of a solution. What are the properties here? The properties, first one, solution is a homogeneous mixture, and the particles of solution are smaller than 1 nanometer. In the particles which is present in the solution, those are smaller than or less than 1 nanometer. They are very small. We can't see with our naked eyes. Okay, and here these solutions, the particles in the solution, we can't see with our naked eyes. Okay, that means that much they are mixed with the solute and solution. Okay, solute and solvent. Okay, then next here the concentration of the solution. How much concentration means there is a concentration of solution we have to study now. There is a mass by mass percentage. So that is a mass by mass percentage of the solution is nothing but how we can calculate mass by mass percentage of the solution. There is a one formula, that is a mass of solute. Already you know the definition of solute, which will get dissolved. It is called solute. Mass of solute divided by mass of the solution. Mass of the solution. Solution is nothing but after the adding of solute to the solvent, the mixture is called as a solution. The mass of solute divided by mass of solution into 100, nothing but mass by mass percentage of the solution. The next, mass by volume percentage of the solution. Mass by volume. So what is the mass by volume here? Mass by volume percentage of the solution is nothing but mass of solute divided by volume of solution. That is the mass by volume is nothing but the mass of the solute divided by volume of the solution into 100. So by using this formula we can calculate the concentration of that solution. That is the first one is the mass by mass percentage, and second one is the mass by volume. Third one is a volume by volume. Okay, third one is what? The volume by volume. That is nothing but the mass of volume. Mass of volume divided mass of volume. Mass by volume percentage divided okay. So here mass by volume percentage is nothing but mass of solute divided by volume of solution. The next one, third one is a volume by volume percentage. Volume by volume percentage is nothing but volume of solute divided by volume of solution. So that is a volume of solute divided by volume of the solution. So that is nothing but the mass, the volume by volume percentage. Okay, just here once again revise here. The concentration of a solution is nothing but here mass by mass percentage of the solution. To calculate that, there is a formula: mass of solute divided by mass of solution into 100. And second one, mass by volume percentage of a solution is equal to mass of solute divided by volume of solution into 100. And the third one is a volume by volume percentage. Volume by volume percentage is nothing but volume of solute divided by volume of solution, so into 100. So that is nothing but these are the three formulas to calculate the concentration of a solution. Okay. The next after the solution, the next one is the suspension. So suspension and colloidal solutions. Okay. So suspension is nothing but here it is also one of the mixture. It is also one of the mixture. Okay. So now we have to study about the suspension. Okay. Okay. So here after the solution we have to study about the suspension. So what do you mean by suspension? So suspension is also the mixture, but the suspension is a heterogeneous mixture. Usually the solid particles which here the solids are dispersed, means we can see the solid particles in the solution. So that's why the difference between the suspension and the solution is different. So solution means we can't see the particles. The particles are very small in the solution, but in the suspension there are small particles. They are visible. We can see with our naked eyes, and they are dispersed. The solid particles dispersed in the solution. So that is called as a suspension, and the suspension is a heterogeneous mixture. Suspension is nothing but heterogeneous mixture, and the suspension we can see with our naked eyes, and when the suspension usually when it is undisturbed, the solid particles they get settled down at the bottom. So that's why easily we can separate by the filtration process. By the filtration method we can separate the suspension. Okay, see here. So the difference, it may be confusion. What is solution and what is the suspension? Suspension and solution both are mixtures, but suspension is nothing but it is a heterogeneous mixture, and solution is nothing but the homogeneous mixture. Solutions, in the solution the particles are very small, we can't see with our naked eyes, but in the suspension the solids are dispersed, we can see with our naked eyes, and easily we can filter, and if the suspension it is undisturbed, the solid particles they will get settled down of the tank and all. Okay, so that is what the suspension. So here suspension is nothing but suspension is a heterogeneous mixture, and solids are dispersed in liquids. So usually dispersed means we can visible. Okay, they are not mixing completely in liquids. That is called as a suspension. The particles do not dissolve but remain suspended throughout the bulk medium. Means they will not dissolve completely. If they dissolve completely, it will become what? The solution. But the particles they will not dissolve completely, and they are suspended at the bottom of the tank, at the bottom of the glass. Okay. So then what are the properties of suspension here? So what are the properties? So first one, suspension is a heterogeneous mixture. Why? Because some particles they are not suspended or they are not dissolved. Okay, so that is nothing but suspension is a heterogeneous mixture, and they scatter the light. Scatter means dispersion. Okay, the light will be get scattered through the particles through this suspension. Okay, but in the sugar solution and in the salt solution, in the complete solution, the light will not get scattered. But in suspension, the light will get scattered by the minute particles, that is the suspension. Okay. The next, the solute particles settle down when the suspension is undisturbed. When the suspension is undisturbed. Sometimes what happens, if the suspension when it is undisturbed, the solid particles they settle at the bottom and they collect at a particular place. So that is nothing but the solute particles settle down when suspension is undisturbed. Okay, see here once again. So what is the suspension here? Suspension is nothing but solids are dispersed in liquids. Dispersed means visible, they are not dissolved completely. Okay, so that is solids are dispersed in liquids is called as a suspension. Suspension is nothing but it is a heterogeneous mixture. It is a mixture. Which type of mixture it is? A heterogeneous. Why it is called heterogeneous mixture? Because there is it will not get a complete dissolve. Means it will not dissolve completely. Okay. Then the particles do not dissolve but remain suspended throughout the bulk of the medium. Means the particles usually they do not dissolve. They do not dissolve completely. Some particles, solid particles, they dispersed in the medium. Okay. The next one, the properties of suspension. What are the properties here? Here the suspension it is a heterogeneous mixture because there is no complete dissolve. Means the suspension will not dissolve completely. The next, these scattered beam of light. Means when the ray of light, when the bundle of lights passing through the suspension, there is a scattering takes place. Dispersed takes place. So that is the scattering of light takes place through the suspension, and the solute particles settle down when it is undisturbed. After some time, if there is no disturbance, then the suspension they will get the solute particles, the solute in the solvent, the solute will be settled at the bottom of the tank or bottom of the vessels. So this is about what the suspension. Okay, I hope all of you have understood about the suspension. Okay, earlier we have studied about the solution, then next it is a suspension, and the next one is a colloidal solution. Okay, the next one, after the studying of solution and the colloidal suspension, next topic that is about the colloidal solution. Okay, so what do you mean by colloidal solutions? Before studying that, we should know about the suspension. Suspension and colloidal solution both are colloids, both are the heterogeneous mixtures. Means they will not completely dissolve, they disperse. But here the colloidal solutions they dispersed throughout the solution. The particles of the colloids are uniformly spread throughout the solution. But in the suspension, they are settled at the bottom when it is undisturbed. But here they will not settle at the bottom, and here in the colloidal particles we can't see with our naked eyes. Okay, they are so minute. Okay, comparing to the suspension. Here the particles of the colloids are uniformly spread throughout the solution. Here the solution, particularly the colloidal solutions, are nothing but they are dispersed uniformly throughout the solution. But in the suspension, what happens? In the suspension, usually they are dispersed, but in a bulk in any one space, but it is not throughout the solution. Okay, and here with the help of the filter paper we can't separate the colloidal solutions. It will not get filtered. And the example for the colloidal solution is a milk. Milk is a colloidal particle. Okay, the particles are very minute. We can't see with our naked eyes. Milk is a solution. Which type of solution it is? A colloidal, and easily the scattering of light takes place through the colloidal particles. Okay, so here the colloidal solution is nothing but the particles of a colloids are uniformly spread throughout the solution, and it is also the heterogeneous mixture. Why it is a heterogeneous mixture? Because the particles they will not dissolve completely. Okay, in the solution what happens? The particles completely dissolve, but in the colloids and suspension they dispersed in the suspension they dispersed in bulk, but here they dispersed uniformly in entire solution. Okay, that's why. So it is the colloidal solution is a heterogeneous mixture. Example, milk. Milk is one of the example for the colloidal particles. And next, because of the small size of the colloidal particles, the colloidal particles are very small. So hence we can't see with our naked eyes. We can't see the colloidal particles in the milk. Just take the milk, observe the milk in a transparent glass. So what happens? Milk we can't find any particles, separate particles. Okay, because they are very minute and very small. We can't see with our naked eyes. So this here, so what is the colloidal solution here? Colloidal solution is a heterogeneous mixture, and the particles of the colloids are uniformly spread. They are uniformly spread throughout the solution. Entirely in the solution they are spread uniformly, and they will not suspend or they will not get collect at the bottom. Okay, like the suspension, but they are spread uniformly toward the solution, and it is a heterogeneous mixture. And example for the colloidal solution is a milk. Milk is an example. Milk is example for the colloidal solution. And in the milk and the colloidal solutions, because of the smaller particles, we can't see the particles with our naked eyes. Okay. The next, after this, here then what happens? Scattering of light takes place. Okay. If you pass the torch, or if you pass the beam of light through the colloidal solution, there is a scattering of light takes place, and that effect is called Tyndall effect. What do you mean by Tyndall effect? Tyndall effect is nothing but the scattering of light through the colloidal particles is called as what? The Tyndall effect. Just here, the scattering of beam of light is called as a Tyndall effect, and this effect, which is nothing but the light will get scattered only through the colloidal particles. Okay, the scattering of light through the colloidal particles is called as a Tyndall effect. The next, what are the properties? The properties of a colloids. Okay, the question is here. What are the properties of solution? What are the properties of suspension? What are the properties of colloidal particles? Okay, so all are mixtures. Solution is also mixture, suspension is also mixture, and colloidal particles are also mixtures. But again, there are two types of mixtures: homogeneous mixture and a heterogeneous mixture. So homogeneous mixture, example solution. Solution is an example for homogeneous mixture. But in heterogeneous mixture, again there are two types. That is the suspension and the colloidal particles. So what is the difference between the suspension and the colloidal particles? Suspension, also the particles were visible with our naked eyes, and they are suspended at the bottom of the tank and all. Okay, but here the colloidal particles, they are invisible. We can't see with our naked eyes. And the suspension, in the suspension we can filtrate. We can filtrate with the filter paper. Filtration process takes place in the for the separation in suspension, but here we can't filter the colloidal particles because they are spread or they disperse throughout the solution. Okay. The next properties. What are the properties of the colloids? It is a heterogeneous mixture. Already we know that colloidal solutions is a heterogeneous mixture, and the size of the particles are too small. That's why they do not settle down. They do not settle down, and the size of the particles too small. We can't see with our naked eyes. So many the colloidal particles. There are so many particles are there, but they are not settled down, and they are very small. Hence we can't see with our naked eyes. Okay, but when the beam of light passes through the colloidal particles, we will get scattering. Scattering takes place. It means that mixture is not a homogeneous. It is a heterogeneous mixture. Okay. So the next one here, they do not settle down. If they settle down, that is called suspension. If they do not settle down and we can't see them, that is called as what? The colloidal particles. The next, they can't separate. It means we can't separate the colloidal particles from the solution by the filtration process. By filtering them, we can't separate that one. Okay. So see here, these are the properties. So question may be asked like this: what is the solution? What are the different types of solution? Write the properties of solution. Okay. Okay. Next, what is the suspension? What are the different examples for the suspension and what are the properties of suspension? Then what is the colloidal particles or colloidal solution? Give the example and then explain the properties. Okay. These all means each carries 3 marks question. What is the solution? What is the suspension? And what is the colloidal solutions? Okay. Up to this, so what is the Tyndall effect? We will study now. So here the Tyndall effect I will explain now. Just here with the diagram. One diagram is there. So what is the Tyndall effect? Scattering of beam of light is called as a Tyndall effect. Okay. So here in the Tyndall effect takes place through the colloidal particles. Okay. So colloidal particles means when the light is scattered through the colloidal particles. Okay. Just here. Okay. So here the Tyndall effect. The Tyndall effect usually in the solution, take the solution like a sugar solution. Okay. In sugar solution, the scattering doesn't take place. Okay. In the sugar solution, when the light passes, okay, when the light passes through it, the light will not scatter. Light will not scatter. It directly passes through the sugar solution. But in the colloidal solution, there in the colloids or colloidal particles, the light will get scattered. Means it will be scattered. Okay, so we can see the scattering of light. So the scattering of light, the process of scattering of light through the colloidal particles is called what? The Tyndall effect. Okay, so Tyndall effect is nothing but when the light scatters through the colloidal particles is called as a Tyndall effect. Okay, so here the Tyndall effect takes place. For example, in milk. The milk, if you take a milk in the glass, when the torch means a beam of light passes through the milk, it will get scattered. But in the sugar solution and all, the light particles means a beam of light, it will not get scattered. It means what is the Tyndall effect here? Tyndall effect is nothing but the scattering of light, beam of light through the colloidal particles is called as what? The Tyndall effect. Okay, I hope all of you understood about the solution and the next suspension. The next one is the what? The colloidal particles. All these are the mixtures. All are the mixtures, but different types of mixtures are there. That is what do you mean by mixture here? Mixture is nothing but 2 or more substances combined physically is called as a mixture, and the mixtures are of 2 types: homogeneous mixture and heterogeneous mixture. Okay, in the homogeneous mixture, example solution. And what is the solution? Usually solution is a homogeneous mixture, and the particles means completely dissolved. Okay, for example, take a solute, sugar. If you take the sugar solution, sugar is a solute and water is a solvent. Okay, when the solute dissolves in the solute like a sugar dissolves like a solvent water, the entire sugar water, that is called as a sugar solution. The particles are very small and we can't see with our naked eyes, and also the solution we can't filtrate. We can't filtrate with the filter paper. Okay, the next one. The heterogeneous mixtures are of 2 types. That is, one is a suspension, another one is a colloidal solution. So suspension is nothing but so here the solid particles means they dispersed the solid particles in a certain bulk. So that is a suspension, and suspension, if it is undisturbed for after some times, the suspended particles, they are settled at the bottom, and we can easily separate with the help of the filter paper. Okay, then and in the suspension also scattering of light takes place. And the next one is the colloidal solutions. So colloidal solutions are nothing but these particles are very small. We can't see with our naked eyes. Example, that is what? The milk. Milk is the example, and the colloidal particles usually they scatter the light. The scattering of light through the colloidal particles, that is called as what? The Tyndall effect. Okay, milk in the milk bottle, take a transparent glass and fill with some quantity of milk and take a torch, pass the beam of light, it will get scattered, and that effect is called as a Tyndall effect. Okay, this much you have studied, and each question is solution, colloidal particles and suspension, each carries 3 marks. Okay, and the next one, separation, we will study about the separation and all. Okay, in the next class. Okay, thank you. Okay, the next, after the colloidal solutions, how we can separate that one? Already we have studied the mixtures. How the mixtures are separated? The mixtures, sometimes what happens, solid mixtures we can separate by hand picking method, by sieving or by filtration, we can separate that one. But if they are completely dissolved, okay, if they are completely dissolved, and sometimes by the filtration or hand picking method we can't apply there, means by that process we can't by that methods we can't separate them. Okay, but here just here the heterogeneous mixtures can be separated by simple physical methods. Usually the heterogeneous mixtures, for example by the filtration we can separate, or sometimes by hand picking method we can separate. Okay, and by sieving we can separate. But sometimes if the suspended particles they are by the filtration they are passing or they are passes through the filter paper. If they are passes through the filter paper, then how we can separate? Just here how to remove the cream from the milk. Okay, cream from the milk. So that is already milk is an example for colloidal particles. The particles are suspended and they are very minute, means very small, we can't see with the naked eyes. But how we can separate them? You already know that the pasteurization process and all, the milk pockets, they have written that toned milk, pasteurized milk, toned milk. Okay, so that toned means what? Okay, here how we can remove the cream from the milk? By there is one process is there. Okay, that process is called centrifugation. Centrifugation is nothing but we can separate the suspended particles in the mixtures. Okay, so that is the solid particles in a liquid. The solid particles in a liquid are very small and pass through the filter paper. Usually they are passing through the filter paper. Filtration process or filtration method, it will not apply here. Then there is one method. That method is called centrifugation. By the centrifugation method, we can separate the cream from the milk. Okay, cream from milk. So that is called as what? The centrifugation method. Okay. The next after this, here centrifugation method is also used in the washing machine to dry the clothes. Centrifugation method will be used there, and also in the laboratories, in the diagnostic centers or in the laboratories, the blood, usually the blood components and all, to separate the suspended particles of the blood, we are using that the centrifugation method. Okay, centrifugation method is also one of the method to separate the particles or mixtures when the solid particles are very small. Okay, we can by this method, by using this centrifugation method, we are separating the cream from the milk, and also this method is also used to separate the butter from the buttermilk. Okay, so that process is nothing but that centrifugation method. Okay, so centrifugation method, where the centrifugation method is used to separate the cream from milk in the diagnostic center or in the hospitals or in laboratories, the blood to separate the suspended particles in the blood, we are using the centrifugation method, and in the washing machine to dry the cloths and all, centrifuge or centrifugation method will be used. Okay, the next what happens here, when the homogeneous mixtures or when, sometimes what happens when immiscible liquids, when two or more immiscible liquids they are mixed, how we can separate? Okay, how we can separate? That's the separation of immiscible liquids by the separating funnel. Okay, so here one instrument or there is one apparatus is there, that is called as a separating funnel. We are using the separating funnel for the separation of two immiscible liquids. Two or more immiscible liquids. Okay. So here separation of immiscible liquids. Separation of immiscible liquids. Separation of immiscible liquids. Okay. Immiscible liquids. Okay, here how we can separate the immiscible? Immiscible liquids means both are liquids with different densities, like oil and water. If the oil and water mixed, take a coconut oil, groundnut oil, petrol. Okay, when the oil and water usually they will not mix. The oil and water they will not mix. Means oil float on the water because of their different densities. The oil density is lesser than that of the water, hence that will be float and that will be separated with the help of the separating funnel. Okay, just here. Okay, in the separating funnel, okay, here this is called as a separating funnel. How we can separate the immiscible liquids? So for example, oil and water. Okay, so here if we take the kerosene oil and water. Okay, kerosene oil and water. Kerosene oil and water. Okay, just here the separation of immiscible liquids. Separation of immiscible liquids we can separate with the help of the separating funnel. Take one separating funnel, and here the separating funnel at the bottom there is a one stopper is there, and if we put the both mixture of water and kerosene, we can observe or we can see the separate layers here. Kerosene oil. So usually the kerosene oil it will be float on the water because of the what? Lesser density. Because of less density, the kerosene oil it will get float on the water. Okay, here we can see two immiscible liquids with the help of separating funnel. Just on the take one large beaker and just on the stopper. Okay, just start the stopper. Then what happens? The water up to the water level, when it reaches to the stopper, up to that we have to flow that one. We have to collect that one. Then when it reaches to the kerosene oil, we have to stop the stopper and we can separate. By this method, it is very easy method to separate the two immiscible liquids with the different. Usually, it is very easy because they are having the different what densities. Okay, here the density of oil and density of water. So we can easily separate with the help of this separating funnel. Okay, take one separating funnel and the mixture of kerosene oil and water put into the separating funnel. Take one beaker and start the stopper. Okay, then what happens? The water up to the water mark, the water will collected in the beaker. When the kerosene layer reaches to the stopper, then stop it. Then easily we can separate the kerosene oil and the water by this method. That is called as a separation of immiscible liquids. So this method is called as what? The separation of immiscible liquids, and the apparatus is used in this method, that is called as the separating funnel. We can separate the separating funnel. With the help of the separating funnel, we can separate the two immiscible liquids. And the next one, how we can separate the salt and camphor. Camphor camphor and salt, they both are solid particles by the sublimation process. Already we know that the salt and camphor, how we can separate that one with the help of the sublimation process. Separation of okay, see here separation of camphor and salt by sublimation. Okay, already in the first chapter we have studied what is the sublimation. Sublimation is a process of direct conversion of solid to gas, that is called as a sublimation. So here take one large watch glass, put the mixture of camphor and salt. Take one inverted funnel. Cover with cotton plug. Close with cotton. Then next is a watch glass. Keep this on the tripod stand. Heat slowly with the burner. Okay, see here the sublimation process, the separation of camphor and salt by the sublimation process. Separation of camphor and salt by sublimation process. How we can separate these two solids? Both are solid here. Before that we studied about the two immiscible liquids, that is kerosene oil and water. With the help of the filter paper, with the help of the separating funnel we can separate it. But here both are solid, camphor and salt. So by which method we are using here? Sublimation. So what do you mean by sublimation? Sublimation is a process of directly conversion of solid into gas. So that is called as a sublimation. Then just here take one watch glass and take a mixture of camphor and salt into the watch glass, and then take one inverted funnel, close with one cotton. Okay. Then next what happens? Slowly apply the heat by the burner. Then what happens? The camphor, there is a sublimation takes place. The solid camphor directly it converts into gas. And it will be after the complete conversion of solid camphor into gas, and slowly just off the burner. Stop the supply of heat. Then what happens? After some times allow this for cool. Okay, after some times without disturbance allow for the cooling process. Then what happens? The solid campers they will be collected at the edges or at the surface of the inverted funnel. So the salt solution remains on the watch glass, but the camphor will collect on the surface of the inverted funnel. By this method we can separate the two solids like camphor and salt. Okay, this here separation of camphor and salt by the sublimation process. Take one, both are the solid particles here. Take a watch glass and take a mixture of camphor and salt into the watch glass, and take one inverted funnel, cover the top of the inverted funnel with the cotton, and then next here apply heat. Means start the burner, and when we apply the heat, the sublimation process takes place. The camphor is a sublimate. Camphor is a solid sublimate. It directly converts into gas. The solid camphor converts into gas. Then stop the applying of heat. After sometimes the gas particles again directly they convert into solid and they collected at the surface of the glass panel. Okay, and by this way the remaining salt solutions or salt particles they are placed at the watch glass only. By this method we can separate the camphor and salt by the sublimation process. This process is called sublimation. Sublimation means what is sublimation? The process of directly conversion of solid into gas is called as what? Sublimation. Understood of this one? Okay. The next we have to study the separation of miscible liquids. Two miscible liquids means two mixed liquids like acetone and water. Okay, acetone and water, how we can with the different boiling points and melting points we can separate that one. Okay, so here that in that process we are going to study about the distillation process and fractional distillation process. So how we can separate the two miscible liquids, two or more miscible liquids. Okay, I hope all of you understood up to this. Okay, thank you.